Hi, hello everyone. This video was made to help those learners that has difficulty in multiplying numbers using the algorithm method. It also aims to help teachers to teach their learners learn the competency in multiplying numbers in an easy and concise manner. So, here we go. The name of this method is WPA method. W stands for right, P stands for product, and A stands for add. As such, WPA method means write the product and add method, in the sense that you just simply write the products of the digits being multiplied without regrouping, and after that, add the digits by column. We will start our example with a one-digit multiplier. For example, if we have 532 multiplied by 4, like the traditional way of multiplying numbers, there are some steps to be followed. The first step is we will start multiplying the multiplicand with the lowest place value, that is from right to left, same as the algorithm method. So to start, we will multiply 4 by 2. The second step states that we will always express the products to a two-digit number. So if we multiply 4 by 2, the result is 8. Following the second step, we will write 08 instead of a single digit 8. The second number to be multiplied by 4 is 3. The third step tells us to align the ones of the succeeding products to the tens of the previous products. In this case, our previous product is 08, and precisely our succeeding product will be 12. That is the product between 3 and 4. So the alignment will be like this. The ones of 12, which is 2, will be aligned to the tens of the previous product, 08, which is 0. The third and last number to be multiplied by 4 is 5, which is equal to 20. Again, following the third step, the ones of 20, which is 0, will be aligned to the tens of the previous product, which is 1. There has been no number to be multiplied by 4, so let us take step 4, which is adding by column, and disregard zeros at the leftmost of the product, if any. So the sum of the first column is 8, the second column is 2, the third column is 1, and the last column is 2. Therefore, the product between 532 and 4 is 2128. Let's try another example. If we have 148 multiplied by 6, again, we will follow the steps. With regards to step 1 and step 2, we will start multiplying 6 by 8. Then we write 48. Next digit to be multiplied by 6 is 4. Then we write 24. Aligning the ones of 4, the ones of 24, which is 4, to the tens of the previous product, 48, which is 4. Next to be multiplied by 6 is the digit 1. which gives us a product of 0, 6, aligning the ones of it, which is 6, to the tens of the previous product, which is 2. Since there has been no number left to be multiplied, then we will take step 4, that is adding the digits by column. So the first column has the sum of 8, the second column has the sum also of 8, the third column has the sum of 8, and the last column has the sum of 0. Since there is a 0 at the leftmost of the product, then we will remove or disregard it. So answer will be equal to 888. Let us proceed to the next example. We will be multiplying 7,319 by 2. So we will start multiplying 2 by 9. That will give us 18. Next to be multiplied by 2 is 1, which gives us 0, 2, aligning the 2 to 1. Next digit to be multiplied by 2 is 3, which gives us 0, 6, aligning 6 to 0. The last digit to be multiplied by 2 is 7, which gives us 14, aligning 4 to 0. There has been no digit left to be multiplied. Then we will proceed to step 4 by adding the digits by column. The first column will have the sum of 8. The second column is 3. The third column will be 6. The fourth column will be 4. And the last column will be 1. Therefore, the product between 7,319 and 2 is equals to 14,638. That's all for the single digit multiplier. Let's proceed to two or more digit multiplier. For example, if we will multiply 532 by 14, again, there are steps to be followed. The first one is we will follow the steps in multiplying numbers by a single digit multiplier. The second is we will start multiplying the multiplicand by a multiplier with the highest place value, that is from left to right. It is precisely the opposite way of multiplying numbers using the algorithm method. So, in this case, we will start multiplying the multiplicand by 1, which is a digit in the multiplier with the highest place value. From that, we can have the first partial product. So, by following the first step, we will multiply 1 by 2, which is equal to 0, 2. Next is 1 by 3, which is equal to 0, 3, aligning 3 to 0 of the previous product. Next is 1 by 5, which gives us 0, 5, aligning 5 to the ones of the previous product, which is 0. We are through with the digit 1. Thus, we have our first partial product. Next digit in the multiply to be multiplied will be 4, where we will be having the second partial product. In this case, we will follow which states that for the succeeding partial products, align each tens to the ones of the previous partial product. Since 4 is the second digit in the multiplier, its first product should be written just below the first product of the first partial product, or just simply write its product beside the second product of the first partial product. So we will write the product between 4 and 2 beside 0, 3 or just below 0, 2, which gives us 0, 8 as the product of 4 and 2. Same will be done to the succeeding products. Next to be multiplied by 4 is 3, which gives us 12, aligning 1 to the ones of the previous partial product, which is 3. Then the last number to be multiplied by 4 is 5, which gives us 20, aligning 2 to 5. As we can see that we are exactly following the third steps, where we align the tens of the succeeding products to the ones of the previous partial products. Since there has been no digit left to be multiplied, then we will proceed to step 4, which is adding the digits by column, and we will disregard zeros at the leftmost of the final product to get the final product. Okay, so the first column has the sum of 8, the second column has the sum of 4, the third column has the sum of 4, the fourth column has the sum of 7, and the last column has the sum of 0. Since there is a 0 at the leftmost of the product, then we will remove or disregard it. So our final answer will be 7,448. Let us take the second example. We have 4,732 multiplied by 684. In this case, we will be having 3 partial products. The first partial product will be coming from the products of 6. The second partial product will be coming from the product of 8. And the third partial product will be coming from the product of 4. So we will first make our first partial product. Again, following the first and second step, we will start multiplying the multiplicand by the digit 6. So 6 times 2 will give us 12. The next digit to be multiplied by 6 will be 3, which gives us 18, where we align the ones of 8, which is 8, to the tens of the previous product, which is 1. Then next digit to be multiplied to 6 will be 7, which gives us 42, aligning the ones of it, which is 2, to the tens of the previous product, which is 1. Then next digit to be multiplied to 6 will be 4, which gives us 24, aligning the ones of it, which is 4, to the tens of the previous product, which is 4. We are through with the digit 6, and we will proceed to the digit 8. In this case, we will follow the third step, which states that for the succeeding partial products, align each tens to the ones of the previous partial product. Since 8 is the second digit in the multiplier, then we are going to write each first product besides 18, which is the second product of the first partial product. 8 times 2 will give us 16. Then next digit to be multiplied to 8 will be 3, which gives us 24. Next digit to be multiplied to 8 will give is 7, which gives us 56. And next digit to be multiplied to 8 will be 4, which gives us 32. As we can see that we are exactly following the third step, wherein the tens of the succeeding partial product. These are the tens of the succeeding partial products. Were in line or were aligned to the ones. These are the ones of the previous partial product. So we exactly following the third step. The ones of the previous partial product were in line to the tens of the succeeding partial product. Same will be done to the products of 4, which is precisely our third partial products. So we will start multiplying 4 by 2, which gives us 0, 8. The next to be multiplied by 4 will be 3, which gives us 12. The next to be multiplied to 4 will be 7, which gives us 28. And the last number to be multiplied by 4 will be 4, which gives us 16. Again, in this case, we follow exactly the third step, wherein the tens of the succeeding partial products were aligned to the ones of the previous partial product. Okay. So since there has been no digit left to be multiplied, then we will take step 4, which is adding by column and disregarding 0 at the leftmost, if any, to get the final product. So the first column will have the sum of 8. The second column will have the sum of 8. The third column will have the sum of 16. So we write down 6 and we regroup 1/10. Then the fourth column will have the sum of 10. This is 18, 20, 26. So we write down 6 and we regroup 2. Then the fifth column will have the sum of 2, 3, 5, 10, 13. We write down 3 and regroup 1/10. Then we have 1, 5, plus 7, 12. We write down 2. We regroup 1 here. Then the last column will have the sum of 3. Therefore, the product between 4,732 and 684 is equal to 3,236,688. That's all for this video. I hope it can help you a lot. Please subscribe for more videos about math lessons. Thank you and God bless us all.